Hey everyone, and welcome to today's Explainer. We're diving straight into Amazon's $10 billion push to blanket the globe in broadband. You probably knew it for years as Project Cooper, right? It was a pretty secretive endeavor. But after that massive rebrand to Amazon Leo in late 2025, they've officially shifted from research to reality. We are looking at a truly staggering effort here. We're talking custom silicon, space lasers, and literally the largest commercial rocket procurement in human history. Let's get into it.
Here's our roadmap for this explainer. First, the space internet race. Second, inside Amazon Leo's tech. Third, the Bezos versus Musk rivalry. Fourth, the FCC deadline drama. And fifth, when can you actually connect?
Okay, Section 1, the space internet race, connecting the unconnected.
To get why they're pouring billions into this, we have to look at the massive hole in our global digital infrastructure. I mean, it's so easy for us to take high-speed fiber or 5G for granted, right? But terrestrial networks just can't economically reach everywhere. Right now, there are over 300 million people worldwide without reliable broadband. We're talking rural villages in Central Africa, indigenous communities in the Amazon basin, and even super isolated parts of North America and Europe. This is a huge opportunity for non-terrestrial networks, satellite constellations, to step in and bridge that digital divide. By putting the infrastructure up in space, you entirely bypass mountains, oceans, and thousands of miles of incredibly expensive underground cables.
So, checking out the current scoreboard for mid-2026, the contrast is pretty wild. SpaceX's Starlink obviously has a massive lead with nearly 10,000 active satellites. But look at Amazon Leo. They are rapidly scaling up to become the third largest constellation. They've already surpassed several legacy providers, hitting around 351 active satellites in orbit. And they are definitely not stopping there. Their factory in Kirkland, Washington is actually designed to pump out up to 5 satellites every single day. That is a frankly astonishing pace for manufacturing space hardware.
Moving right along to Section 2, inside Amazon Leo's tech, re-engineering the constellation.
But getting all that metal into space, that's only half the battle. It's really about what the hardware does once it's up there. Unlike the older geostationary satellites that hover nearly 36,000 kilometers away, which honestly is like routing your internet traffic around the entire planet before it reaches your laptop, causing that super frustrating lag, Amazon Leo operates in low Earth orbit. That's just 600 kilometers above us, and because it's so much closer, it cuts latency down to a snappy 20 to 40 milliseconds. That means real-time video calls, cloud computing, and even telemedicine become totally viable no matter how remote you are.
Now, the real secret weapon here is Amazon's custom-built Prometheus chip. You know, in the space industry, every single ounce of weight costs an absolute fortune to launch. So to make this network economically viable, the hardware has to be incredibly light but wildly powerful. By taking what used to require multiple, heavy traditional chips and consolidating them into one piece of custom silicone, Amazon drastically cut down the weight and power consumption of each satellite. And what's really brilliant is that this single, super-efficient chip processes a massive 1 terabit of data per second in space, while using that exact same architecture to power the terminal sitting right in your backyard.
And this tech is exactly how Amazon avoids relying entirely on ground stations. They use optical inter-satellite links, which are basically just infrared lasers, to beam data at 100 gigabits per second across distances up to 2,600 kilometers. This creates a continuous mesh network right in space. Think of it like the satellites are passing a digital baton to one another without ever having to touch the ground. So say you're on a ship right in the middle of the Pacific Ocean. Your data doesn't need to hunt for a local ground station, it just hops across the satellite network until it hits a continent, completely bypassing terrestrial bottlenecks. It's so cool.
Which brings us to Section 3, the Bezos versus Musk rivalry. 2 billionaires, 2 philosophies.
What's really driving this rapid innovation is a modern-day space race between 2 totally distinct deployment philosophies. We are watching this play out impartially in real time. On one side, SpaceX's Starlink uses a move first, optimize later approach. It is all about relentless speed, iteration, and aggressive public beta testing. On the flip side, we have Amazon's strategy: wait, develop, then launch. They've spent years focused on disciplined, deep integration. They specifically want to link this satellite infrastructure directly into their massive AWS cloud network, prioritizing reliability and enterprise-grade performance way before opening the floodgates to regular consumers.
To catch up quickly to SpaceX's massive head start,
Amazon actually orchestrated the largest commercial launch procurement in human history. They booked over 80 flights across 5 different rocket families just to eliminate any single point of failure. They are flying on United Launch Alliance's Atlas V and Vulcan Centaur, Ariane Space's Ariane 6, Blue Origin's New Glenn, and yep, they even swallowed their pride and bought flights on SpaceX's Falcon 9. By spreading a $10 billion budget across multiple providers, including their biggest rival, Amazon is making absolutely sure that a delay in one rocket program won't ground their entire network.
Listen to this quote from Amazon CEO Andy Jassy. "We believe we can provide a better value for customers, including more affordable pricing than what's currently available." That statement basically sets the stage for a massive price war. It clearly signals Amazon's intent to use their massive e-commerce and cloud computing scale to potentially undercut current market rates. And you know, when two well-funded giants compete for the exact same users, the ultimate winner is usually us, the consumer. We get better hardware, faster speeds, and eventually lower monthly bills.
All right, Section 4, the FCC deadline drama, the ticking clock in orbit. But, as always, it's not all smooth sailing. All these tech innovations and launch contracts were recently overshadowed by a pretty massive regulatory hurdle. Because space is a shared resource, you can't just claim a radio frequency forever without actually using it. Looking at their timeline, that November 2025 rebrand to Amazon Leo marked a huge shift from research to reality, right? They launched prototypes in late 2023 and production satellites in April 2025. But this timeline also put a giant spotlight on a critical threat: the original July 2026 FCC deadline, which required 50% of their entire constellation to be in orbit. And that became known as the July 30 problem. The FCC has this standard use it or lose it clause. It's kind of like claiming a plot of land. You can't just put up a fence, you actually have to build the house, or the government takes the land back. Amazon needed 1,618 satellites operational by that specific date to keep their spectrum license. But thanks to early rocket development delays across their partner network, Amazon only had roughly 351 satellites in orbit by mid-2026. Hitting that 50% milestone didn't just look hard, it was mathematically impossible.
So, what happened? Well, the FCC's final ruling ended up being a neutral compromise. Amazon was saved from losing their license entirely when the FCC waived that impossible 2026 milestone, though they did keep the final 2029 deadline in place for the full 3,200-plus satellite network. But there was a major catch. Amazon got slapped with a 20-month spectrum demotion. In plain English, this means if both networks are beaming signals into the exact same area and they cause interference, Starlink's network gets the regulatory right-of-way, and Amazon has to yield. It's a quiet but super significant strategic victory for SpaceX.
Now for our last section, Section 5, when can you connect, rollout, and pricing. With all that regulatory dust finally settling, let's talk about what this means for your actual connectivity. Because let's be real, the grandest space infrastructure in the world only matters if we can use it. Amazon has designed 3 distinct DIY terminals. First up, the ultra-compact Leo Nano for basic needs and smart devices. Then you've got the standard Leo Pro, which is under 11 inches square, expected to deliver up to 400 megabits per second and cost less than $400 up front. And finally, for heavy enterprise or government use, there's the Leo Ultra, offering gigabit speeds. The crucial takeaway here is that all of these are designed for easy self-installation. No need to wait around all day for a technician to show up at your house.
Now for the million-dollar question. What's it going to cost? While official monthly pricing isn't completely locked in just yet, industry analysts project Amazon is going to use its vast ecosystem to aggressively undercut the competition. A standard residential Starlink connection sits at around $120 a month in the US, but Amazon Leo is projected to target the $85 mark. And of course, there is wide and honestly very plausible speculation about integrating this with Amazon Prime, potentially offering bundled discounts so they can capture market share really fast. I mean, that feels incredibly on brand for the retail giant, doesn't it?
So when is this happening? Well, once Amazon hits the 578 satellites required to provide continuous initial coverage, they call that Phase 1, beta service will officially light up. They're targeting late 2026 or early 2027 across 5 northern nations: the US, the UK, France, Germany, and Canada. A free public waitlist is actually already open right now. Plus, their totally unexpected April 2026 acquisition of the satellite company Globalstar was an absolute strategic masterstroke. It brought in licensed spectrum and regulatory approvals in over 100 countries, literally setting the stage for incredibly fast global expansion the second the hardware is up in orbit.
As we wrap up this explainer, I want to leave you with a thought. Can a disciplined corporate giant actually outmaneuver an agile early adopter?
And how will this ultimate clash of philosophies reshape the way the world connects? We are literally witnessing the birth of a brand new utility layer in orbit. And whether you eventually place an Amazon Leo or a Starlink terminal on your roof, the reality is that the digital divide is finally shrinking. Thanks so much for joining me on this deep dive, and I hope this helped you make sense of the massive shifts happening right above our heads. See you next time.